Hey, welcome to D-Electric again, but we're not going inside quite yet. We're going to go to a remote location and see some brush maintenance being done. So, let's go take a ride. All right, so what we're going to be looking at today is a brush maintenance at a customer's plant. So we time to time get called by a customer to come in and perform some maintenance on a DC motor. DC motors often get dirty inside because the powder from the brushes, as they break down as they're running, get inside the motor, and they can cause some problems. So again, we're going to be looking at a brush maintenance job today. So we are at the customer's location. The first thing we're going to do is pull the blower off and do a visual inspection. So we'll just do it just to look in and see if there's anything out of the ordinary, anything we see right off the bat. We also will document how many brushes are in it. So you can look down in and see the brushes that are in there. This particular one, again, there's 6. So there's 3 on the opposite side from where the technician is standing and 3 on the side where he's standing. So it's 6 total. We'll document everything as we go. We document the motor nameplate and the sizes of things as we go. So after we do the visual inspection and check the number of brushes, we take the first side off. And right inside the cover, once the cover is taken off, you can get to the brushes. So we do, again, a visual inspection, make sure we don't find anything loose or broken, and then we'll take the brush springs out. And there's a little clip on them. You can just unclip them and pull them right out. The brush springs, so we check them too and make sure they're in good shape. And then we'll actually take the brushes out and check the brushes. And the brushes, as you can see in the picture, the brushes have a little bit of streaking on them, which actually matches the commutator. But we'll take all the brushes out on this side and check them, and then we'll move to the other side once these are out. The other thing we do as part of our inspection is to check the leads. So we'll take the lead box cover off and inspect the leads. And obviously, before we start the job, we do our lockout tagout, so we know it's de-energized, so we can go in here safely and do what we need to do. So again, we're looking for any kind of overheating issues, any kind of arcing. If we see any arcing, we look and see if the protection is hooked up. Some motors have motor protection, some motors don't. This particular one does, but basically we're just inspecting it to make sure the leads are in good condition. So again, inside, once the brushes are out, we'll check the commutator again and look and see what kind of condition it's in. Whether there's some streaking. In this particular case, there's some streaking and some threading going on a little bit, but it's not terrible. In this particular case, it's not something that needs to come out and be worked on. But we will, again, document what we find in there. And also we're checking the grooves. So in between the copper bars, there is mica. And the mica has to be cut below the surface of the copper. It can't stick up. Because if the mica actually comes in contact with the brushes, it'll wear the brushes significantly. So that has to be undercut. So when you talk about a turn and undercut, that's why we do that. We turn it to clean it up, and then we cut the slots so that the mica is below the surface. So the other thing we're documenting, as I said before, we document stuff we find. We document the brushes. In some cases, we know what they are if we've been there before, but we write down, this particular case, they're Hellwigs, which we knew, and they take the number, if there's any numbers on the brushes, and document them. And then we measure them. We measure the width and the length of the brush and document that. But then we also check the height of them to see if there's how much wear is on them. And we'll check every one of them to see if they're worn the same or if something is wearing more than something else. And it may indicate a problem if you have one that's worn down halfway and one that's still sort of almost new length. The other thing we do is, as part of our normal procedure, is check the conduit. So we check, make sure everything's tight, no loose conduit connections, including the tachometer on the back of the motor. Make sure everything's tight and not loose. Again, that's just part of our standard procedure. We also check the riser, which is the back end of the commutator. So we check the riser to make sure that there's no solder visible. If it gets hot, it'll throw solder, and you could actually see the silver on it. In this particular case, it looks fine, but it's just another spot that we check. So there's a few different problems you could find with commutators. Pin arcing is one. Obviously, wear patterns, grooving, threading, streaking, all that. And then the actual color of those, you can see where the three sets of brushes are riding. And in this particular case, it's like a chocolate brown. That's a decent color. It's something that means there's not any issues going on. So in this particular case, this motor is not going to need anything. It just needs cleaning up and putting the brushes back in. So then lastly, after we have everything checked and documented, we blow it out. If they're really bad and a lot in there, we'll vacuum it first. But certainly we blow it out to get all the carbon and dust that we can out of there on both sides, in the comm, through the motor if we can, and outside of it as well. In the lead box, we'll blow as much out as we can just to get it cleaned out. And then after he's done cleaning it out, next thing would be to put everything back in, put the brushes back in, put the covers back on, put the top end back on, and obviously the lead box cover. Everything would have to be replaced the way it was. And then that's pretty much what we do when we do brush maintenance. So why don't we head back to the shop and see what else we can find back there. Okay, welcome back to the shop here at D-Electric. Hope you got some good information out of that brush maintenance. We're going to see now what we have in the shop today that we can look at. Okay, so this is an armature that we are rewinding. So as you can see, it's been stripped and been cleaned. This is a new commutator. So we have the new commutator that we have put on it. So it's on, and at this point, he started putting a couple of equalizers in. So these equalizers span all the way across from one side to the other. When he's done, it'll be equalizers filling all these slots all the way around it. And then once the equalizers are in, then he'll put a coil in. So this is just a sample that I have here. But this coil goes in, and then these all go down in the slots. They'll get cut off even with the end of this when it gets put in. And then the end of that, when all the coils are put in, the end of this gets TIG welded. So it makes a good connection with the commutator itself. So as I mentioned, this commutator is a new commutator. In the brush maintenance video, we talked a little bit about the comm and the riser. So you can see much easier in this that the riser, this is the riser we were talking about. That's where all your wires from your winding get connected. And then also you can see this one. This one's obviously new, so it's shiny. There's no grooving or anything going on. But you can also see the mica in between the copper bars, and it's even with the top right now. So once this gets wound, this will have to be turned, and then we go in there, we undercut so that mica is below the surface, so it does not touch the brushes. And that's kind of what we were talking about with the mica and the riser on the other video. So this one's ready for rewind. All right, so what we're going to be looking at next is a gear motor. So this is the motor portion of it, and as you can see down here, the gear broke off of the shaft. So you can see the shaft is still in there. It came right off, broke right off, and there's actually a fracture in the shaft here itself. So it fractured pretty bad when it broke. This particular job is a Eurodrive, so we've already checked into it. We can buy a new shaft, new rotor shaft to put in this, but the motor runs, so we think the rest of the motor is going to be good. Let's take a look at the gearbox that goes with this. All right, so this is the gearbox that goes with it, and obviously the motor bolts right to the front here. So you can see the gear inside here. That's the mating gear to the one that was broke, so that's going to have to be replaced as well because there's some damage there. And obviously you can see it's in the press right now. We're working on it. But on the back side here, we also have broken gears inside there. There's a chip on the input gear that probably happened when this thing, when the front end broke, whatever caused it to snap, probably jammed the gears and it caused some chipping on some gears. So it looks like we may be replacing a number of gears, if not all of them, in this gearbox. But once we get all apart, we'll be able to assess all of them to see how badly the rest of them are damaged.
Hey, thanks for stopping by D-Electric to see what's going on this week. Next up, ready.
Welcome to Redding Bearings and Drive Solutions. Let's take a walk in and see what's going on in the shop. Holy tangled wires, Batman! What's going on here?
Robin, this is our automatic coil winding machine. I'll have Tom show you its capabilities.
All right, once we get a job in here, we can put all of our data information into our computer system. It will save all of our data information for if we ever have a job late or come back in, we can pull it up and set everything up. Once we're all set up here, all we got to do is flip a switch and we can set our machine up to what sizes we need for the coils, brace it up so that our coils don't break down. As Robin said, we have a big batch of wires here. The one nice thing about this machine, as this winds, it will lay those wires into the coils perfectly so that they will go back into the stator a lot easier. Once everything's set up, everything's down, start up. Now the machine will go on its own, giving me the freedom to go cut insulation for the job, saving me time, and also saving another person to be working with me. We can also speed it up. Another nice thing about the machine is we also have photo sensors on the wire coming through. We lose a bucket, goes empty. it will shut it down automatically that the wire will not go inside the coil and get lost. I can get the wire repaired with another bucket and then finish the job off. We also have a safety. Once you pull this up, this will stop. And as you can see, all the wires are laid in line with each other.
This is a completed job we have in our shop. This is a special transformer. Why it's special is because it's 220, 300 volts primary. Secondary is 10 volts times 2 to the center tap. It's an obsolete transformer, so we had to rewind it for the customer. Regular transformers are really not worthwhile rewinding if it's one you can get down at your local supply house, but this is a specialty. It's labor intensive to rewind a transformer like this because of the laminated steel in the top. As you can see, they're interwoven, so they have to be taken apart one sheet of steel at a time. It's probably about maybe 75, 100 pieces in there. Slide the coils off the top. The primary winding is down on the bottom, and then they rewind the secondary winding on the top, which is the heavier wires. This is the primary windings, the smaller wires. When this unit came in, the secondary coils were shorted. I have some still photos that we'll put on this video, and you can see they were roasted and starting to coil apart. So what we had to do is take apart, rewind the primary, secondary coils, put it back together, and interweave the laminations on between the two pole pieces. And unit's ready to go back to the customer.
As part of our commitment to our customers, we do ongoing training. Inside this room, you're going to get a chance to see one of our Miller service techs who's in the process of doing virtual training. Thanks for taking your tour today of Redding Bearings and Drive Solutions and D Electric. We hope to see you real soon. Enjoy your day.